Everybody, my name is David Stinemetze. I am a manager of software development at Rackspace here in San Antonio. I manage the team that works on Rackspace.com, which sees millions of users a month. It's quite a heavily trafficked website. It's a fun project to work on, fun website to work on. Definitely not without its challenges. If you are interested in connecting with me further, you can find me on GitHub or Drupal.org with @widgetsburritos. And my Twitter account is just my first and last name, so if you have anything to share or any thoughts afterwards, please connect with me. I definitely appreciate any feedback, positive, negative, whatever. Just let me know what you think. So this talk is a historical page load time monitoring using WebPageTest and Drupal. It kind of is a mouthful, but you'll get what I'm getting at if you're a little confused. Maybe not, but we'll see as we move forward. So I'm going to start by asking a question. Why is page load time important? And let's see what the answer is. But what? Why did I do this stupid animation? It's going to take forever. Yes, as you can see, this was intentional, but because people are, what are people? People are impatient. And so the longer people have to wait, the more annoyed we get. Obviously, that was a little lighthearted joke there, but real users, when they're trying to access real websites and consume real services, they're not so amused by a silly little animation. If it prohibits them from actually getting things done or consuming or purchasing a product that they want to purchase, they may just go somewhere else. And so I'm not just saying this, there's data to back it up. In 2017, Akamai released these findings in their State of the Online Retail Performance Report. A 100 millisecond delay in website load times can hurt conversion rates by 7%. So just a tenth of a second can have dramatic impacts on how much you're bringing in. A 2-second delay in web page load times can increase bounce rates by 103%. And 53% of mobile site visitors will leave a page that takes longer than 3 seconds to load. To follow that up, around the same time, Google released some industry benchmarks for mobile site performance. Basically, if your website goes from 1 second to 3 seconds, you increase your bounce rate by 32%. 1 to 5, increase by 90. 1 to 6, increase by 106. Increase 1 to 10, your bounce rate goes up to 123%, or increases by 123%. So this is just, these are studies, these are reports that Google and Akamai have done. What about like real user data? Well, fortunately with Rackspace, we were able to go the other direction. And so let's just take a look here. So since 2017, these have been our page load times. So you can see in 2017, we started at around 5 seconds. At its peak, it got to about 7.5, 8 seconds. But you can see along 2017 and 2018, we started to see some dips in our page load time. Well, carrying that on, look at our bounce rate from the same time frame. I forgot to update this slide, but that's actually supposed to be the same time frame as well. And you can see that these maps correlate pretty well. As our page load time was reduced, so was our bounce rate, which means people were staying on our website longer, they were engaging with our content longer, and they were actively seeking out our services, presumably. So there are other factors involved than just page load time. I don't want to make it seem like it's the only factor, but you can see here there are definitely direct correlations to them. So much so that this little spike right here in page load time was mimicked in the bounce rate right here. So we had like this weird little spike. I don't know exactly what that spike was, but we had it. And when that happened, it corresponded with the bounce rates. All of this data is pulled directly out of our Google Analytics install, so they can provide some basic page load time analysis if you use Google Analytics. But you can see right here that we were able to map load times to our bounce rates. And so this is real data. This isn't just some study someone else did. This is actually customers on our website. Does that make sense? Any questions on that so far? All right. So let's ask the question, how do we measure page load time? So there are some important metrics. Now, for the sake of this talk, I'm going to be using terms and metrics as defined by the WebPageTest tool. You may use other tools to monitor page load time, and if you do, you may see other variations. There's going to be similar, but they may use other words. But for the sake of this talk, we're going to just stick with these definitions. So let's just talk through a few metrics. So, time to first byte. What this means is when a person goes and they go try to hit a website, this is the amount of time it takes for them to get the very first byte back from the server. A lot of times this can be impacted by things like DNS, SSL negotiation. Maybe there's some long-running thing happening in PHP on the back end of your server. That's what this metric really helps measure. Start, render, or first paint. So if you are going to a website, this is the very moment, the very amount of time it takes for the very first thing to show up in your browser. Now, that may not be content. It could just be a background image or background color change. It just kind of depends on how the page was assembled. But this is the very first thing that becomes visible on a user screen, indicating that something's happening. First contentful paint is actually when the first bit of content is rendered on the page. So this is the actual useful information for customers. So not just when it starts rendering, but when you actually provide something meaningful to a potential customer. Load time, which is kind of what we're focused on here, is the measurement from when someone hits the website or hits the URL to when the document complete event occurs. So a quick show of hands, are you all familiar with JavaScript, DOM ready event, document complete? Anyone not familiar with that? Okay, so if you're familiar with that, that's basically what we're measuring, how long it takes for the document to complete. Every bit of HTML that was on the page when the page was loaded actually gets processed by the browser. It doesn't mean things that external JavaScript events or whatever have actually fired. It just means that they've been processed by the browser. And then there's the fully loaded time, which the way WebPageTest defines this is it's 2 seconds, or it's looking for the first 2 seconds of inactivity or idle time after the document complete event. So as soon as you get the document complete event, it goes a certain amount of time, and then it says, okay, now we have 2 seconds of inactivity. So when that 2 seconds starts is where they measure fully loaded. Is that clear? They also have this magic metric called the speed index. Just curious, anybody used WebPageTest before? No? Okay. So they have this magic metric called the speed index. It's kind of fascinating. They have this whole page on it explaining all the maths, which reminds me of college calculus. Like, I barely understand what's going on. But the idea behind it is essentially what they're doing is when they do a capture on a website to go measure time, they actually record video. And what they will do is they will measure how long it takes to get about 90% of the screen drawn. And when that happens is when they mark the speed index. And so that is relative to user visible content. So if you have a mobile display or a desktop display, it might be different. It's just what's in the user's screen when it shows up. But that's kind of a useful metric, but it's not necessarily useful on its own because there are a variety of factors that can go into it. But it is useful for doing A/B comparisons between separate websites or maybe before and after deployment, those kinds of things. You can monitor whether or not your changes have impacted your page load time in any way. They also provide a metric called DOM elements. So this is essentially the number of unique HTML tags that are loaded on your page at the time the website is fully loaded. So at the very end, once all the JavaScript's fired, all the other stuff is triggered, it counts how many elements are in the total DOM. And we'll see some visuals of that here in a little bit. So those are the main metrics. And then there's a couple of views that I want to focus on. So there's the first view. So all metrics are captured on a browser with cleared cookies and cache. So what this means is this is basically simulating a first-time user. A user who's never been to your website before comes and hits your page. They don't have any of the cookies or cache or whatever. So they come hit the page, and the first view simulates what their experience is. And then there's the repeat view, which does the same thing, but instead of it clearing out cookies and cache, it actually loads it a second time with the cookies and cache and checks to see what it's like for a repeat visitor who has all that stuff enabled, and you can monitor how much caching has helped optimize your time. And we'll see some visuals of that as well. So before I move on, any questions on any of these metrics or views?
I have a quick question.
Yes, sir.
WebPageTest. There's a WebPageTest.org, and that's citing sites.google.com, whatever. What's some of the difference between those?
Well, so they just hosted their documentation on sites.google. You can see right here, it's in a directory called WebPageTest.org. But yeah. Any other questions? Okay. So there are a bunch of different tools out there for measuring page load time. I'm only going to focus really on two, and even one of those I'm going to briefly touch. Google Chrome tools, if you ever use the dev tools inside Chrome for whatever, there's a network tab in there. Anyone ever use the network tab? Okay, so people are familiar with the network tab, so we'll go over that pretty quickly. WebPageTest basically provides everything that the network tab provides, but then a lot more, which is why it's useful. Other tools worth exploring, Google Page Insights, Google Mobile Speed Report, GTmetrix. Those are worth checking out. I'm not going to talk about them today, but there's plenty more out there as well, not just those, but those are some good ones. But let's just take a look real quick at the Google Chrome dev tools. So as I mentioned, most of you are familiar with this, but if you haven't seen this before, when you load a URL, it gives you this waterfall view of all the connections that are made after your initial connection. And so what I did is I actually loaded the URL for this session in my Chrome browser, and we can see what we've got this waterfall, which we can actually, if any of you have used this before, you can probably see there's a couple of things that could probably use some optimization here. But what we see here is, first of all, I've disabled all cache because I'm trying to simulate the first-time user. But this first connection right here is the connection that comes from the server, and so this happens in about 0.3 of a second. And then what we see is the rest of the waterfall gets triggered after that. And so we see a bunch of CSS files, images, JavaScript files, more images, some fonts loading, some images, more scripts, more images, more scripts, more images, more scripts, more images, the fav icon. So we have a lot of stuff loading after the fact. Well, some of what we're loading here, though, it gives you an idea of where some of our problems could be. Anything that's taking large amounts of time to load can sometimes be problematic. And what we can see here is we have two images that are taking at least 5 seconds. This one's taking almost 7 seconds to load. And why this is problematic is a browser can thread its resource connections. Like it can do a certain amount. I think it's like 4 to 6. I don't remember the exact amount of connections it does simultaneously. But the more things you have loading, the more you have potentially blocking everything else from loading. And if it's something that has visual implications to a user, they may think, okay, well, the page is not still loaded, and it's going to delay how long of the perceived load time that user has. So, and as we showed previously, the longer that perceived load time is, the more likely those users are just going to be to leave. So there's definitely some room for optimization on the Texas Camp website. If you go look and see what these are, one of them is the big snake image that loads, that animates. So, it's an animated GIF, so to be expected, that takes a little while to load. There's also at the very bottom of the page, there's like a little silhouette of like the state of Texas. That's kind of a footer. That's sort of an afterthought, but it's really a huge image that probably should be compressed down significantly. So, because it's a PNG and it probably should just be a JPEG file. So those are the kinds of things that you can use Google Chrome developer tools to identify. And you can also use WebPageTest for that. And so I took that same URL and I plugged it into WebPageTest.org. So any of you can go to WebPageTest.org at any time. It is a free website to use. Go plug in any URL you want, and you can go get a report that looks something like this. Now, this one is slightly truncated because I only had so much space. But you can see we have here, it actually ran 3 times, but it shows you 2 different runs. And what it does immediately is when it scans is it does 3 subsequent runs of the site. So that way it kind of helps give you the best of all worlds and averages, so you remove some of the variability of, well, maybe there was just a little hiccup in the network connection here. It gives you a little bit more of a stable result by having 3 that it then can combine. But you can see some of those metrics we talked about, load time, first byte, start render, first contentful paint, speed index. A lot of those things are in here. There's another one, last painted hero. I'm not going to focus on that today. Feel free to dig into that a little bit more. But you can see really the numbers here. And what we get here is our average load time is about 8.6 seconds. And a lot of that comes from those images. And we could see something similar with Google Chrome. But let's go ahead and take a look at this further. So if I go click into one of these and I go click into the waterfall, we get something like this. And you'll see it looks somewhat similar to what we saw with Google Chrome previously. But it gives us a little bit more information just off initial glance. One, we can see all the host names that are getting connected. You can see that in Google Chrome, but you have to like mouse over each one or expand the column really wide, and it's kind of hard to deal with. This right here actually says, hey, look, these are all loading from 2019.texascamp.org. This one's loading from the back end. If you're not aware, Texas Camp website is a GraphQL website, so it has a separate GraphQL back end. So there's a couple times I had to go reach that, which oddly enough, it's only loading images from that, so that probably should be resolved as well. You can see we have a couple connections to Typekit. We actually have 5 connections to Typekit, so that's where all the fonts are coming in. We have a few more from texascamp.org. We have Google Tag Manager and Google Analytics coming in later. And so Google Tag Manager, Google Analytics, those aren't necessarily blocking tags unless you have functionality getting served out of Google Tag Manager. But all this visual stuff is definitely something that may impact the users. Any questions so far? Yes?
So what are the main things that we should be focused on? Because there's a lot of information here. Like which one should I be more focused?
So that is a very good question, and I think a lot of times it depends on what you're seeing. Usually the idea here, things you would want to focus on, or anything that's taking a long time to load, like anything that's spanning really wide in the waterfall is usually a good starting point. As you start fine-tuning those things, you might start noticing other things, but I would, like, if I looked at this, the very first thing I would say is these images are just too big. And I would start there, and then what I'd do is I'd rerun the scan again after we fix those issues, and then we would see, hey, what happened next? Now what can we go optimize? Does that make sense?
And on top of that, there's a table, like the table which says load time, first byte, start render. So which one should I be concerned about?
All of them. No single metric is the magic solution for page load time. It's a combination of those. Now, I would say if you're looking at a single one to kind of note your overall trend, I would say just the regular load time, which is the document complete event. Because that's at least when users will consider it visually complete. And so I would say that's the metric to probably give the most attention to. But I can't say that that's the only one to do, because that is impacted by time to first byte. It's impacted by start render. And we'll see some of that when we get onto the next steps. Yes, sir?
So if you continue on that, so maybe this image is in the footer. It's not affecting the human that's below the fold. They don't necessarily see that. So from that perspective, the person sitting in the chair, maybe not a concern, not a priority, although it's easy to compress on what we're doing.
Sure.
So low-hanging fruit. But then again, there are other audiences like Google, who's determining page speed and SEO rankings, and whether or not you can place ads on the mobile service, et cetera.
Absolutely, yeah. And that's a good thing too to point out as well, because Google definitely takes page load time as a factor when it considers SEO. It's not the only factor. I mean, there's some competing ideas of how important it is, but it's definitely a factor they look at. And so, especially if your site is on mobile indexing on Google Search, Google Webmaster, which I believe is all of them now. I can't remember if they've made the switch to all of them. But if Google is indexing a website as a mobile-first website, then you want to make sure your site is optimized for mobile. Make sense? Great call-outs, thank you. All right, so taking the waterfall a little further, WebPageTest also provides tables that look something like this. So this takes the connections that we saw in Google Chrome, but it adds a little bit more context to it. So you can see here we have a DNS Lookup column. And I apologize, the font may be a little small to read, but you can always check it out in your browsers separately if you want to look at this further. But you can see how long a DNS lookup takes. And so this is an important thing. If you're loading everything from your local host or your your single host, then you only have one DNS connection that has to be made. But as soon as you rely on Typekit, you rely on Google Analytics, Google Tag Manager, perhaps you're using some sort of digital tagging with DoubleClick or Twitter or Facebook pixels, the more things you add into the fold, the more it starts pushing that ultimate like fully loaded time down. Now, if you implement them properly through something like Google Tag Manager that kind of defers it and like converts them into like non-blocking tags, it may not impact the user, but it still could impact things like Google. So that's just worth pointing out. Okay, does that make sense? But you can see, like, this is how long a DNS looks up. It's also, just got to make that network connection. Also, if it's an SSL site, which most likely it should be, it's got to take extra time to do SSL negotiation. Then it's got to go download the content, and it gives you like a total of how much was downloaded. And God forbid you ever get an error or a status code other than 200. You get 301s in these connects that are doing redirects. Well, then it's having to make sometimes multiple DNS connections, multiple SSL connections, etc. So these are things to be considering and thinking about when you're looking at your page load time. Cool? All right, so we might now ask the question, well, where does Drupal come into play besides the fact that we're hosting a Drupal website that we care about page load time? Well,
one question, sorry,
yeah.
before you go back.
Yeah. Oops, sorry.
What can you do if for your domain the DNS lookup is slow?
This is actually a problem that we're trying to talk about right now because we've noticed some variability in ours as well. One of the things you can do immediately is bump up your TTL. The time to live count. Like right now, I believe Rackspace.com, our TTL is set to like 5 minutes. So that means every 5 minutes, somewhere, something is re-looking up that DNS connection, which is not necessarily the best thing. So if you get to a place where you can actually prolong that TTL, the amount of time basically that hostname gets cached in certain networks, it can help reduce the amount of time it takes for that initial DNS connection to occur. Now, you only have control over your own domains there. You don't have control over Google Analytics. You don't have control over DoubleClick or all of these other host names. You can only focus on what you can focus on. But that's why you need to try to take a strategy to defer the loading or maybe like lazy load some of those external resources if you can.
You might be covering this, but you can also prefetch those.
Yeah, I will briefly mention that, but yes, that is a good call. You can actually, so there's another module on Drupal.org that we actually maintain called the Resource Hints module, and if you install it, you can actually say, go pre-connect these URLs, and what it will do is it will add some headers. You can either do it as a header, like a response header, or you can actually do it as link tags, or I believe it's link tags, in the head of the doc. And it will actually go tell your browser to go pre-connect to those domains earlier in the waterfall, so it actually helps optimize some of those page load times. Caveats there, and something we're still trying to figure out whether or not it's a problem, is when you get into the context of things like GDPR, which is people opting out of digital tracking in the UK. Is pre-connecting to these ad service domains allowed? Or is that considered a violation of GDPR? I think it's still new. Like, there's a lot of, and for those who are unaware, it's GDPR was a data tracking thing that came out of the UK. It impacts us because we have like a UK website, like in a UK business. Actually, it's all of Europe, and so I believe California is passing legislation similar to that goes into effect next year as well. So these are things that are going to continue to be a concern. But the question then becomes, if you pre-connect to these ad services, are you in violation of GDPR? And so those are the questions that have to get asked. And so there's a trade-off between legality and page load time that you're going to have, that are probably going to pop up soon. I haven't seen a whole lot of discussion on that, but it's something that we've been talking about a little internally. So fun times. All right. Does that answer your question?
Yeah.
So, okay. So how does Drupal come into play? So it's not just having a website hosted on Drupal. We actually have a module that we built and we're building called the Performance Budget module. You'll see it's still in alpha, so it's still kind of in its infancy, so we definitely can use some help, and we'll talk about that. But I'm sorry?
Can you go back?
Oh, yeah. The Performance Budget module. Yeah. You ready? Okay, cool. All right, so it is an alpha release module currently built for Drupal 8. Our goal is to make sure it's supported for Drupal 9 as well. When it's on our roadmap, we haven't got to it yet, but at least got rid of the deprecation, so we're close. But the purpose of this module right now as it stands, it's not complete, and we'll talk about future goals in a little bit, but what it currently can do is it can provide historical performance trending if you set it up to go capture on specific URLs. And I'll show you kind of how to do that here in a little bit. But it was built on another module that we also maintain called the WebPage Archive module. I'm assuming most people aren't familiar with it because we haven't done a whole lot of broadcasting, but I did do a talk on it last year at Texas Camp if you happen to be in there for it. But that module you can find on Drupal.org. I'm not going to click on it, but you can just see the purpose of that module is it was originally built to be a screenshot archiving tool, so we could go capture screenshots on a list of URLs. So you provided a list of URLs or an XML sitemap or whatever, and we just set it up to automatically run in the middle of the night, and it'll go crawl our website and take screenshots. We did it for legal reasons, so if our prices say something on day X versus day Y, we can go prove that kind of stuff. So that was why we built that, but we built that as a open source Drupal module that you can use. We then expanded some of the functionality to do HTML capturing and visual regression, so you can actually use those screenshots and then do visual comparisons of that. And while this talk is not on that module, I'll actually have a brief example of that later, because it does tie into this talk. And then what we realized is essentially what we had done is we had built, while we had a specific use case in mind when we built it, we had built more of a generic just go capture and compare system where all we were doing is supplying a list of URLs. We wanted to go do something to those URLs, capture that data, store it on our system, and then potentially later go do some comparisons with that data. Well, at that time we realized, hey, why not do page load time performance as well? So we ended up building a capture utility that uses WebPageTest. Because WebPageTest is free, it has a free API that we can use. And so we spent all this time getting it, configured to capture data, and then business needs changed, and it fell off our radar for about 2 years. But we picked it back up because we were starting to look at D9 deprecation issues, and we're like, oh, let's just go fix the deprecations in this module. And so we started fixing those modules, but what we realized is, oh wait, we've been capturing data for the past 2 years, but we have no idea what any of it actually shows because we were capturing it, but we had no way of visualizing it. So it kind of piqued our curiosity a little bit, and I ended up taking a lot of this effort in just building a tool to take that data and then start visualizing it. And so at this point, I'm assuming you want me to stop talking and actually show you what that looks like. So, all right. Everybody see this? Actually, I'm going to shrink it back down a little bit so it's the chart's within the scope. So this is 2 years of performance data. Now it may seem a little confusing, it may seem a little like what am I looking at first, but I'm going to go through and I'm going to point out a few things that I find important. First of all, the first thing I'll notice is back here in November of 2017, there was this really, really big spike here. You got to take these really huge spikes out of the equation sometimes because network variability can sometimes come into play here. You're using a service to go over the internet to go capture like performance metrics. Any single day's worth of data is not necessarily meaningful. What is meaningful is the overall trends. Who knows what could have happened this day? And actually you can click into this day and go see kind of what took so long. I'm not going to do that right now. But I would say the first thing I'd point out is you see spikes like that, just kind of ignore that kind of thing. But what we'll see up here is at the top of this chart, we have a couple different metrics here, a couple different lines. We have the first view load time, we have the first view fully loaded, we have the first view time to first byte, and the first view start render. And so I want to outline or highlight a few events that occurred. All right, so let's take a look here at the beginning of June, and we see this drop right here. All right, so you'll notice on June 6th here, we were above kind of this trend line. And starting on June 7 and moving on further, our time to first byte dropped by half. And this is kind of a cool thing to see, because what this corresponds to is June 6th was the day we migrated from Drupal 7 to Drupal 8. Right here, we can visually see the impacts on time to first byte between Drupal 7 and Drupal 8. And what happened with Drupal 8? We got Symfony involved. We got Symfony's caching layers involved. We got all of Drupal's additional caching layers on top of Symfony's caching layers involved. And what it did is it significantly dropped the amount of time our backend was processing. So anyone who ever says that Drupal 8 is slower than Drupal 7, they're not doing it right, because this is visual data that proves otherwise. And you can see our time to first byte went from almost 3 seconds to half a second, maybe around that second mark, depending on kind of what day you're looking at. But this just goes to show that the stuff that's happening in Drupal 8 is actually being well thought out. They're making performance a priority, and I feel like this data proves it. So that was the first thing that we noticed here. So I thought that was very cool.
Did you change something on the infrastructure besides just the website, like the web server you were using or something?
We moved it to a different server. I think we may have bumped up the PHP memory limits as well. So there were a few other infrastructure changes that probably impacted it as well. I don't want to dismiss that. But mostly we tried to do parity, like it was A to B parity. When we migrated our site, we tried to do a actual migration. We didn't create a new website and just pull in some content. Like we had the same website before and after. And so from there, we were able to drop it. But yes, there was a few changes around like memory limits that went into play as well. So probably the cost of our server went up a little bit. But overall, we can see that the amount of time it spends processing and loading went down.
But you wouldn't have did that if you would have switched to DA.
Definitely not, yeah.
So the whole point was that you were switching to DA, cut your time.
Correct, yes. So that was really cool to see, because, we knew our page load times were doing well, but we didn't know exactly why. And so what's cool about this tool is it gives us the ability to hone in on specific times, and then we can go map it with all of our Jira tickets and see, okay, well, this is what we launched on such and such a day. You see a big spike and it starts trending upward for like a few weeks. Well, you can go look at that time to see, okay, what did we deploy during that time window that may have impacted this, and what can we do to counteract it potentially? So what this allows you to do is really focus on time windows and just notice that, okay, well, these dates, something went out, something got deployed, and it impacted our page load time, either for the good or for the bad. Any questions on that? So I want to show a couple of other things as well. Let me turn all these metrics back on. All right, so that was that. Okay, so you also notice around that same time, we've got this funky little dip here in first load time. But then, so this second chart is the same thing, but it's for the repeat views instead of the first view. So this is like the second time visitor. And you'll notice actually around the same time, like this got a lot larger. Like these values consolidated, but like these values got bigger. And so, unfortunately, I mentioned it earlier, around the same time we were doing the D8 launch, we also become under scope of GDPR. And so we had to, I think it was at the end of May, we had turned on a cookie consent manager on our website, which was only supposed to impact UK websites. Well, what we've since discovered is during this time block where we see like these dramatic dips, for whatever reason, the server WebPageTest was connecting with was under the scope of that cookie consent manager. And so it was actually never seeing some of those connections occur till the second load, just by nature of the way the cookie consent manager worked. So they ended up resolving it in like January of this year, but it was just one of those things. That was like one of the first things I saw here. I was like, what the hell happened there during that time window? Why is all this stuff down, and then why did it just spike back up? Well, the green line here is the fully loaded, which includes all of the digital tags, like DoubleClick and Twitter and all that stuff I mentioned earlier. And so we have all these other tracking things that are occurring, and for some reason they just were getting blocked during that time window. I don't know if there's anything we could have done to stop that, other than had we had this visualization sooner, we probably could have figured out that's what was happening and maybe made some tweaks to our cookie consent manager to make sure that one wasn't getting in that scope.
What's interesting is it shows you how much overhead this thing actually adds.
Absolutely, and this is the data I'm trying to take back to the people on my side to say, do we need so many tags? What is the value? Can you justify this amount of extra load time? Those are conversations that continue to happen, and wish me luck.
Those sort of problems are political, not technical.
Yeah, exactly. All right, so I want to zoom into one more date before we get back into the other part, but unfortunately when you zoom in too far, the chart library just shows times, it doesn't show dates, so I gotta go figure out where this is. I want to focus in on August 9th here, which is right here. August 9th was an important day because it was the very first day that we were able to visualize any of this data. Like, this is when we actually created our first version of the charting mechanism. Now, what you're seeing now is a couple drafts in. We originally were using Google Charts. I ended up switching to Chart.js because I had a lot of problems with Google Charts. But that was the day we were able to first start visualizing some of this data. Well, what ended up happening shortly after is we discovered a few things. So, I think, let me see, it would be probably on the repeat view where we'd see that best. And I'm going to focus just on, well, here, let's see. Okay, yeah, so let's take a look at this chart. So we can see August 9th was right here, and then at that point we start seeing some downward trends. Well, what happened is we realized something. When we started looking into this data, we were kind of backtracking to the D8 launch. And when I say we tried to get feature parity from D7 to D8, that's not entirely true. We did make a few changes to our system. One of the things we did, and it was because one of the modules we were working with, I believe it was the Google Tag Manager module or Google Analytics module. One of them, I can't remember which one it was, but it was having some issue that was only affecting us when we had aggregation turned on. And so when we launched D8, we actually turned CSS and JavaScript aggregation off. We were relying on the fact that we were already behind Akamai, which does HTTP2, which kind of minimizes some of the penalties you get for multiple connections from the same server. So we just thought, okay, well, we'll just launch the site without turning aggregation on, and we'll just go from there. Well, that was another thing we kind of forgot about. We forgot we had turned aggregation off, and it was making all these connections. And we realized at this point, hey, you know what, we should revisit aggregation because that might be another thing that's going on here. And so actually, if I scroll down here, this other chart here, this one right here is, remember I told you there's a number of DOM elements you can keep track of? Well, you can see we went the wrong direction with our DOM elements, the amount of actual elements that are loading here. But what we'll see is around August 11th or 12th, the number of DOM elements decreased by almost 100, and that's because that's when we turned aggregation back on. And we can see that back up here as well, August 11th, August 12th, these trends are going back down because we realized, oh, we need to go aggregate all this stuff, and that module works with aggregation now. We've resolved all those problems. And then we turned it on, and what we see is we got another performance benefit out of it.
Did you break GTM?
We did not. No, it worked as expected, thank God. It was a risk, but that's why we have staging environments to test. All right, so another cool way to visualize this data. Okay, I want to show you one more event that occurred, and this is going to be, I want to focus on just a couple metrics. I want to focus on, I'm going to take fully loaded out, and I'm going to take time to first byte out. And I am going to zoom in a little further here. Hey Rob, how's it going?
Pretty good. A little late.
No worries. So what I want to show you here is the load times are still bouncing up and down, but remember how I told you all of these times are really dependent on time to first byte. Like whatever time to first byte is, all these other things are going to spike or go down in parallel. So I took that one out of the equation, but you can see that's pretty much true. They're all following this time to first byte. Well, what I really want to show you is what happened on October 7th, or maybe it was the 11th, I can't remember the date, October 7th. You'll see that the separation between our start render, which is when the very first pixel is rendered in your browser, and the document complete event, or the full load time, we ended up shrinking this by half. And what I want to show you is what we did and how we did that. And I did not mean to zoom in there, sorry. Let me get back in there. The charting engine is still a little finicky here, but if I go look at October 7th, and I go look at October 8th, you click into them, it gives you this sort of a summary report, and then you can actually go click a detailed report here. And we can see, we have a few options here. So first of all, we have this Gantt chart. And it's not as pretty as what WebPageTest gives or what you get out of the Chrome Element Inspector or the Chrome Network tab, but it does its job. It shows us a few things. But what I want to show you is I want to compare these two Gantt charts. So you'll notice here we have these block of 4 items here. And then on October 8th, we only have 2. Well, let me show you what those are. If you can see here, we're loading a path here, but if you can read that really small text, it's loading fonts. So on October 7th, we were loading 4 different fonts on our website. They were all hosted on our domain, so we didn't have extra DNS connections, but we still had to go load 4 different fonts. Well, what we ended up doing was on October 8th is consolidated it down to 2 fonts. This one change dropped our overall page time by a half a second or more, because fonts can be beastie, especially depending on which ones you're using. And so in this case, we can see these lines narrowed together where the amount of time basically remember this from here to here measures the visual completion process, where it was, let's say, about 2 seconds here and a little under 1 second here, so it was taking over a second to complete that process. The next day it was from 0.9 to 0.139, so it went down to about 0.4 of a second. So we chopped more than half a second off of our page load time just by getting rid of 2 fonts we didn't need. Now, the question is, what was the visual impact? Now, remember how I mentioned previously that we had built some visual regression tools into Drupal as well, and I was going to briefly demonstrate it? Let's go see what that visual impact looked like. So, see right here, the San Jose Data Center? That is the visual impact. Is that really so much of a problem that we needed 4 fonts? No. Let's go look down here. We don't see much of a noticeable difference. Data center statistics and specifics, they're a little darker. And when I say we had different fonts, we had the same font, we just had different weights of the same font loaded. And so, yeah, maybe here on the quote, we lost a little bit of the strongness there. We were okay with that, because we got to save half a second just by getting rid of this stuff. So at that point, we were okay with making the concession and saying, we don't need this font. And so this just goes to show the power behind having trends of performance data as opposed to just having a single day's worth of performance data, because you can actually see the benefits as you start collecting this data. Because remember, one day you go run WebPageTest, you go looking Google Network tab, in one day you're dealing with a lot of factors. What are the network factors at that time? How long is the DNS server? Well, maybe there was some DDoS attack also in play that's impacting things. By trending things over time, you take a lot of that variability out of the equation. And yes, you still have these occasional spikes, and you learn to deal with them. And then the question comes, are there other things we can do here to improve? Absolutely. We talked about it earlier, the time to first byte, ways to improve it. Well, I will show you right here one of the issues we're having on the days that it is spiking and some of the variability we're getting. It's coming from the DNS portion of the rackspace.com connection. So that is definitely the next thing in our list of things to optimize is what can we do? We'll probably bump our TTL up sometime soon, and hopefully we'll have some more data in a few months to show how that was effective. Any questions about any of that?
What are you going to be bumping it up to?
We don't know. We literally had the idea to bump it up like 2 days ago, so we haven't actually figured out the specifics yet. We're making some other infrastructure changes too that might impact that as well, so it's going to be part of a larger initiative. The other thing to keep in mind with page load time is not everything doesn't happen in a vacuum. There's always other changes happening. Content changes could be happening. We have a CMS, so people could be uploading really large images. I mean, we do try to compress them with Drupal, but still people are able to do bad things sometimes, and so there's a lot of factors that come into play here, but that's why the overall trending is important, because then you can find kind of when, around the time something started to become a problem, and then maybe you can go backtrack it to whatever JIRA tickets you have and just say, okay, well on this day we deployed X, and that was when the problem started occurring. Do you have a question?
Yeah, first off, great job with the module. I think it's a very useful module. I'm just wondering if you could take some of the output and just put it like in a JSON or XML and put it into an elk stack or something so Kibana can make it graphically for you. That wasn't my main question. The main question is, and this is great for like a live site that's going on, but what if you wanted to do it like if you're doing testing instances? You said you guys built this off of the API that WebPageTest has, so that's not too difficult, and it already has a web API, or it has the APIs on the website or something that you can go and use that to kind of go and grab that same data, or?
Correct, yeah, so this is all using WebPageTest API, and so when you go submit a request to them through their API, what they will do is they give you a JSON response. So talking about can you store it in JSON, it's already in JSON in the back. You go look at the file server, there's just a bunch of JSON files. What this is doing is then taking that data, like Drupal is doing, is just aggregating all that data and generating charts. Yeah. So at the core, we just have a bunch of responses that we got from WebPageTest.
Okay, I see what you're saying.
And so if you want to go build your own API and go do your own stuff, by all means, go do it. Like, you don't have to use this tool. It's just, this was something we ended up building that hopefully helps you if you're already part of the way there. You can use for your own.
No, I like the way that you guys did it. I think it was very, very useful. It might save you time, again, just pumping it into an stack. So, because Kibana can just take that.
Sure.
And just pre-build graph stuff. But no, and I like the long-term thing. I'm just thinking, if you're testing, like if you make a change, you spin up a testing instance, you probably want to test it.
Sure.
Opportunity to test it right then and there and say, is this valid?
Absolutely. Just real quick, let me make sure I'm okay on time. We got about 10 minutes left. Okay. So I will show you real quick on the summary here, or I'm sorry, on the charts here at the bottom, we also have summaries. What this did is we've actually sorted host names by average load time, so we can actually see what the problem hosts are too. And we can see, like if we go look at rackspace.com, it's not the problem. It's way down the list. What is the problem? It's Marketo. It's Salesforce. It's all these other digital tags and all these other services that we're being asked to provide support for. So this is also arming you with data to go back to your stakeholders and say, hey, look, do we really need 18,000 digital tags on our website? Because look at what it's doing to our page load times. That's kind of my goal as well, is to get enough data that we can use it. You can also see, you can go reprocess it and go get a little bit more granular and just say, I only care about like the past month or the past week. That's especially important because when you have 2+ years worth of data, it's really slow to process. And yeah, like right now it's only manually reprocessing, so every time I get more data I have to go like rebuild this. But if you want to go like focus on the past week of data, well, there you go. It can go reprocess, and a week's worth of data is a lot quicker to get through. But then what you can do is these domains respond to that, and you can actually see since then, like we still have some problematic connections, but our averages are way lower than they used to be because whatever we've optimized a few of the digital tags we've been using. But I will say we optimized. We've removed a few of the problematic ones.
One question, how much data are we saving in the database? Because like from last 2 years, this much would be how much data, like in megabytes or something?
So every day's worth of data is 1.56 megabytes or approximately. I mean, it may vary, depending on the response we get from WebPageTest. So I'll let you do the math, but you're talking about 300, 400, 500 megabytes per year, something like that. And you don't have to save all that data. You can say, I only want the last year's worth of data, and we've actually built in some functionality where you can set up pruning around that data as well. So you have options there.
I have another question.
Yeah.
So I deal a lot of times with SIP environments, so like closed container environments where it's not accessible from the outside. This is assuming if you're using the WebPageTest API, you're assuming that they can reach your site.
Sure.
Did you guys find any tools that you could use in a closed environment that's not accessible from the outside?
So I think that's a good segue into kind of what's next. So we have a couple things that are next, and I believe it's item 3 on this list. So let me just go through this list now. I'll get to it in just a second. So the module is called performance budget. If you're familiar with what an actual performance budget is, we're not fully there. A performance budget is basically setting thresholds of what's acceptable and what's not, which is the next thing we want to build. We want to actually build in some thresholds to it to say if page load time is ever larger or ever higher than 5 seconds, we want to be notified. And so these two issues, one of them is an issue for performance budget, the other one is an issue for the core web page archive issue. Those are both tied into that same effort. Basically, we need to build a notification system into web page archive that then performance budget can use to then go configure those thresholds and then go get that resolved. So those are the probably first two priorities for me right now. Where you may come into play and what may actually help you is supporting private web page test instances. So if you go look at this link, I should have just clicked on that. If you go look on this issue, it actually links you to here. WebPageTest provides Amazon AMIs that you could go spin up your own custom EC2 instance, and you could go do, and it could be in whatever data center, but you could set up private routes for that specific machine to access your internal network. If that's permitted by company policy, but if you can get that approved, you could actually set up your own dedicated web page test instance without having to worry about their API or variability on their end, and then you're just dealing with an Amazon instance that you just have setting in whatever data center you want.
You'd be able to run it internally instead of in front of you service.
Possibly. I mean, it's all open source, so the presumption is you go grab this code.
You can extract it out of API and AMI to something else, or there are various tools like OpenStack that let you run it.
Yeah. But with that, WebPageTest is open source as well, so presumably you should be able to get it running. I mean, if they're able to build AMIs, that's probably just like the recipe you need to go build your own instance locally.
Basically, it's a Docker instance of WebPageTest that operates inside VPC.
Correct. Now, the caveats there are going to be that if you're within the same network, you're removing, and maybe it's a good thing, maybe it's what you want, but you are removing some of that internet specific variability, like, if,
You can still go out.
yeah.
Yeah, when I set up my testing service, I have my JVM inside of VPC2 and EC2, so it's still, you still connect to outside things.
Yeah.
But it's within your VPC, virtual private cloud, so it's not accessible from the outside.
Okay. Well, I mean, yeah, I guess where I'm getting at is, and I guess you're talking about an internal service anyway, so it's not really a problem, but if you're using like an edge caching service like Akamai or whatever, you're not necessarily seeing the network implications of coming through that. But you're talking about something that's internal use only, so I think from that perspective, that's not necessarily a factor for you because you have to be on the network to access it in the first place. So I'm assuming you could probably build something like that. All right, so we have like 7 more minutes. Let's just try to finish this up, and then I'll gladly answer any more questions as we can. Next on the list was number 4. We want to get some advanced data normalization in play here. And specifically what I want to do here, we saw some of the variability with time to first byte. Everything else is dependent on it. What I'd like to do is try to normalize that data with time to first byte out of the equation and just see what happens, because then you can actually really identify the trends that are happening between those other metrics. Now, I wouldn't always want to do that because time to first byte is still important. I want to make sure we're still able to see what's happening with time to first byte. But I'd like to see some of those other metrics with that taken out of the equation sometimes, because then we can say, okay, well, we're having a problem between start render and whatnot. And we saw that sort of with like the narrowing of the gap between the two lines. But I think if we added some extra data normalization in there, it could provide some useful charts that we could then go take to people and just say, hey, look, these are where the problems are. Then just takes one more variable out of the equation. So there's that. We also want to provide support for Google PageSpeed Insights. So they provide different subsets of data and different metrics that we can use, and grades and whatnot. I want to try to add that support in there. I just haven't got around to it yet. And then there's definitely a plethora of other bug fixes and feature improvements that need to happen. So we have just a short amount of time, so I'm going to go through this really quickly, but For you to get started, I'm just going to kind of hammer through this, so bear with me if I'm going too fast. I will make sure all these slides are accessible, and the video will be accessible as well on texascamp.org later. First thing you need to do is you need to go get an API key from WebPageTest, and until we get that functionality to build your own instance, you'll need that. You need to go install the module. From there, you go into Web Page Archive, you go click this Add Archive button. You go set up a job. Now, there is currently a bug in there. Like with Web Page Archive, we have the ability to run jobs either manually or automatically. With the way Performance Budget is currently built, keep in mind, still an alpha module, it can only be ran automatically. So what I've been doing to manually test this is I'm setting it to run automatically, but then I set the cron tab to run every minute. And then I just go simulate it by running cron, just through Drush or whatever, and that simulates the manual run. Now, granted, I'm doing this on a local instance. You wouldn't want to do that on a production server, but this is really just to get you in there. Once you kind of get your bearings, then you can go from there. So after you add the the job, you then need to specify the WebPageTest capture utility. This is where, like, if you wanted to do screenshot capturing, if you had the other modules enabled, you'd have the option to do that as well here. But because we're specifically dealing with WebPageTest, you'd add it here. Then when you go add it, you add your API key. You specify which KPI group you want, and I can show you that briefly as well in a second. But here, what I'm doing is I'm just issuing a Drush cron to queue up the initial run. Now, WebPageTest does take a few minutes for it to go process the data, so we have to do an initial job to make the initial request, and then we have to come back again in a few minutes and download the request. So if you see this error in Drush, it doesn't mean anything. The error code or the exit status is still 0, so it's not actually failing. It's just the way Drush is visualizing it, but it's not an actual problem. But then when it does work, you'll get a message like this that says process one URL. And then from there, you can look at your job and click the view run history. You can click view details to go see more detailed views that looks like this. We saw the Gantt charts or whatever. You go run it again. That's when this historical report functionality starts coming into play, because you have multiple runs. You can specify your date range that you want to process it on. And this chart was not very useful because it was 4 hours separated. So, but you've seen what it looks like with actual several days worth of data, years worth of data, and how that chart starts looking. You can also look at all the connections that are being made on an individual connection and also over a summary, so you can see Google Tag Manager, Typekit, all this stuff. It's here. And then finally, help wanted. So how you can help, please test the module, please report bugs. If you want to become a case study, that would be tremendous, like someone else using this. Find an issue, come work on it. Help us write documentation. Help us review the code. And that it's not just code reviews, but it's performance reviews, security reviews, Drupal best practice reviews. Also helping us get ready for D9. We can definitely use that. These are all the resources I used here and I mentioned today. Feel free to look at that. And that's everything I have. Thank you so much for your time. Again, hit me up on Twitter, find me on GitHub or Drupal.org. Let me know if you have any questions. I'm more than happy to answer them.
So one question I have, we have the site in 4 different languages. So how this is going to help, like let's suppose my home page is in English, Russian, Chinese, and other language. This will show me, if you can show me the data with the English and might be Russian at the same time. But the Russian timeline could be different than the English, because the servers are set in the East Coast.
Yeah, what you can do is when you set it up, you just set it up to capture your different URLs. Now, if you're looking for separate data centers to maybe you want a Russian server to go hit the Russian language and a Chinese server to hit the Chinese language site, we don't have that in there yet. I don't know if WebPageTest if their API can support that or not. I haven't dug that far into it. Worst case scenario, you can use the AMIs on AWS, go set up an AMI and the closest data center and just kind of simulate that behavior once we get that functionality in. But if that's something that interests you, please help me with that issue, because good. I'm getting people looking at me through the window saying to wrap it up. So with that, if you have any more questions, please just hit me up outside. Thank you so much for your time. Appreciate it.
Thank you.